Hey everyone, can you hear me? Awesome. Well, so take some time to sign in. Do a minute or two. Go through announcements, and then we'll get started. Go ahead to announcements. So only one announcement this week. Next Tuesday, October 27th, we're gonna have a collab with women in cybersecurity. Do a CTF workshop. So if you've been interested in CTFs and you don't know where to start, this would be a good place to start. I don't know that much more information, but if you ask Dago in Discord, he said he'll have a link, so go ahead and hit him up. But with that out of the way, let's get into the presentation. So this is slices of pie. It's basically, concept is if you are like me, you have a problem, buy a bunch of Raspberry Pis for no reason because they're $10. So this is what things you can do with them. So why Raspberry Pis? Well, first of all, they're cheap. Like I said, $10 for one of these. This is Raspberry Pi 0W. We'll go over the different versions in a second. They run Linux. Linux is great because free and easy and everything runs it. So good platform, open source, same thing basically. They're cheap. This one is $40, and it is really a full-fledged computer. Like, these are cool for weird embedded things, but you can get a lot done on a full Raspberry Pi 3 or 4. They have integrated hardware, so you can see. Let me see if this shows up on camera. I have a bunch of I have a circuit board soldered on top of this. And that's because the Raspberry Pi has a bunch of built-in features we'll go over in the demo, which basically means that you can do stuff that you wouldn't be able to do with a normal computer, but you still have Linux to back it. They're well supported. It's dead simple to install stuff. You'll see that in the demo again, and they're cheap. So the different versions, we have the Pi 0W, the one that I have like 4 of for some reason. But there's also the Raspberry Pi 3B. It comes in a little bit bigger form factor. You can see this one has a case on it. But the nice part about these is you have a full-size HDMI port. You have full-size Ethernet jack and 4 USB ports. So you could plug this into something, and I know a lot of people use them for things like like a living advertisement display board kind of thing. And it wouldn't take a bunch of extra adapters. So that's the main issue you'll run into with these Pi 0Ws, is that you need adapters to get from this mini HDMI and get a full-size USB port out of this. So it adds a lot of cost, but I'll show you in a second how we get around that. And then there's the Raspberry Pi 4, which came out semi-recently. It has a lot more power, and you can do things like H.265 encodes with hardware. So if you're not familiar with what that is, H.265 is a compression algorithm or standard for video. So you've probably heard H.264. That's what most YouTube videos are. That's probably what this stream is running on. H.265 just takes a lot more processing power, but if you have the integrated silicon, it's a lot better. So we'll go over that, why that's important in a second. And then gigabit Ethernet. If you want to network a bunch of these together, gigabit Ethernet's really nice. These Raspberry Pi 3s only do 100 megabits, and then the Pi 0Ws don't even have port for that. So you will need a few extra things to get started. You'll need a micro SD card. This acts as the hard drive for the Raspberry Pi. And then you'll need a power adapter, which in the case of all of these is you just take a micro USB and you can plug it in. Now the 3B and the 4 will require a 2 amp charger, but most modern phones use 2 amp anyways, so if you have one laying around, that'll work fine. So the problem with the Raspberry Pi 0Ws is no adapters. I'm cheap, I don't want to buy adapters. So you can actually set these up headlessly, like you would with a full-fledged embedded product. So, you know, if you want, I do have a adapter. This is a USB OTG. Basically adapts the micro USB to a full-size USB. But I still need like a USB hub and a monitor, and I don't have a micro HDMI, nor do I really want to unplug my monitor. So the way that you do this is you can, when you're flashing the ROM with Linux, when you're flashing the SD card, you can add an extra file or two, and I'll show you in the demo how I do that. But it basically means that you can take these, which people always, you know, advertise $8, $10. You can make it to where you can actually use this without spending any more than like $8. So that's pretty great. And again, I'll go over all this in the demo. There's also another tool called Pi Bakery, which if you're doing some weird setups, like you want to be able to set up a Raspberry Pi to where it runs a script on the first boot, or it does something weird with like cron jobs, Pi Bakery is really good for that. It runs in Electron, and if people are interested, I can also go over that. So some of the stuff you can do with it. The most basic one I can think of is run a print server. If you've ever had a printer that has networking that sucks, it's pretty great because Linux has this thing called CUPS. It stands for like Common Unix Printing System. It basically is printer drivers standardized in the Linux kernel. So if your printer supports CUPS, then you can just hook up a USB to a Raspberry Pi, install the CUPS driver, install the CUPS server, and then all of a sudden you'll have a network printer that doesn't suck because it's all standardized and super common in like for like schools and a lot of, if you ever use the ECS Lab printers, they're probably running a similar print server, or I don't know, some weird Cisco proprietary thing, who knows. Some other things, this is like the default project for Raspberry Pis is Pi-hole. What Pi-hole is basically an ad block for your entire network. It's a super simple setup. It could lead to an increase in performance because you're not downloading any ads. So a normal ad blocker in a browser will just hide all the ads for you, but Pi-hole like completely blocks the edge. It makes it as if the servers for the ads are down, and it just does this by doing what's called a DNS intercept. So you set it up, and it acts as your DNS server for your network. So you tell your router to point DNS requests at your Pi-hole, and then the Pi-hole will check against a list. If that's an ad, then it'll just send back a 404, or I don't know, whatever the HTTP code is for a broken request. But and then if it's not an ad, then it'll just forward that to Google or some other server. We'll go over that. I'll set up Pi-hole in the demo. Another thing you can do that's a little bit cool, dumber, I mean, less useful in general, is run a PirateBox. PirateBox is a piece of software that's basically you can flash your Raspberry Pi with it, and then connect to that Wi-Fi, open Wi-Fi hotspot, and you can share files to it. You can chat. None of the stuff's logged. The idea is just it's a kind of public space that's completely anonymous, separate from the internet. If you've ever been to DHA, they have a PirateBox usually set up, although we haven't been to DHA in a while. If it comes back, you guys should go, but obviously COVID. One thing to note is it is kind of a dead project. The creator just doesn't have time for it. It still works, still fine, but if if it breaks in the future, you better get ready to start making pull requests. Another thing you can do, host a VPN. VPNs are super useful. If you probably all know what VPNs are if you're here. If you don't, please ask. But you can set up a Raspberry Pi to be a VPN on your network, and this is nice. It's nice to have a VPN on your own network, because if you're ever outside or you have a bunch of, let's say, little servers that are Raspberry Pi based, that you want to access, you want to SSH into, if you set up a VPN, then you don't need to forward all those ports. You can have stuff changing around on your network. As long as the VPN's up, you don't have to fix it. So it's generally a more secure way to do things. That's why the school makes you VPN in if you want to access the CS servers. And we'll go over that too later. You could add Wi-Fi to your toaster. The 0Ws are really well suited for just doing random IoT stuff. If you've messed around with smart home, like Philips Hue or Ring doorbells or whatever. Ring's not a good example, but it is kind of working. There's a project called Home Assistant, which basically lets you hijack all of those. You can sign up with developer accounts, get Google Assistant working. But there's a standard called MQTT. I don't remember what it's called, what it stands for, but basically it lets you do your own DIY IoT devices. So within Home Assistant, you can have a little toggle switch that you press on your phone, and then it'll toggle one of the GPIO pins of this thing on and off. So let's say you have a garage door that doesn't work. You could hook up 2 wires to it and then just do it through your phone with Home Assistant. So there's some cool stuff to do with those. You can also, there's a project called MotionEye. MotionEye OS is specifically for Raspberry Pis, because every Raspberry Pi has a little header on it. See right at the top there. That's for a camera, and it'll take the raw input from a camera. It doesn't need to use a normal USB webcam. So you can pretty affordably get decent cameras, and MotionEye OS will convert those into webcams that you can use with a MotionEye host server, and use that as your security system. Some cooler stuff, if you're into security, you probably are familiar with a lot of the stuff that Hack5 makes. Most of that stuff, I mean, while it is going to be a lot nicer, the commercial products, but most of that stuff you can kind of DIY or hack together if you need to test something out with a Raspberry Pi. Again, particularly these Raspberry Pi 0Ws, really good for weird hardware stuff, because they can act as what's called a USB host. So let's say you have, for example, a USB keyboard is a USB host. So this can pretend to be a keyboard. So you plug it into a computer, and then as soon as it gets power, you can have it programmed to execute a list of keystrokes that you would use to email yourself some passwords or keys or files or something. And the common term for that is USB rubber ducky. Generally, they just look like normal USB drives that you can like drop outside of somewhere, and then people plug it in without knowing what it is and let it go. But you can test stuff out with your Raspberry Pi. You can also do DNS poisoning. So similar to what Pi-hole does, except instead of having the router point to the Raspberry Pi, what you do is you just hook up a USB to Ethernet adapter to Raspberry Pi and use that as your Ethernet adapter. So what happens is you plug in the Raspberry Pi and the computer sees it as an Ethernet adapter. And it is an Ethernet adapter, but in between you have your Raspberry Pi intercepting requests and changing it to like your own server. So let's say you want a web page makes a request to get some data, you can read that data or change that data before it gets sent on, assuming that it's not secured. And if you've heard of Poison Tap, that's exactly what this is. I don't know how well it works now with HTTPS being pretty ubiquitous, but it's something to know about. You can also do remote GPIO. The GPIO pins have a really nice Python library, which makes it super easy to do these kind of hacky projects. So one of the features that the library has that I haven't seen used a lot is you can actually set it up to where in basically the kernel, it'll monitor another computer to change the GPIO. So you can have it where you're on your desktop and you have I don't know, we'll say the hackery way to do this would be you have a gate that you need to open that you've planted a Raspberry Pi on, and you've connected or clipped or soldered on the two little circuit board contacts to open the gate. Well, you can just forward that pin basically over SSH to your main desktop. It's like a direct hardware thing. So if you ever need to go back and change stuff and you don't have SSH access to it, which I don't know, that's a realistic situation, but if you need to be able to really quickly change the state of stuff, that's a good way to do it. Some other helpful stuff if you're setting up these kind of systems is DuckDNS. If you don't have a domain that you're paying for, DuckDNS is like a free DNS service that has really good tools for setting up on a Raspberry Pi and pretty much anything else. But so you can do, you can get your own domain. You can say csg.duckdns.org, and that'll work. So if your external IP ever changes, then you'll still have access over the internet. Another thing is Let's Encrypt. That's a free HTTPS service. You've probably used it if you've done anything web-based. And there's a really neat tool called CertBot, which works on pretty much every version of Linux, but also Raspbian, the version of Linux for Raspberry Pis. It makes it just super easy to get a DNS certificate or an SSL certificate for your little service. So you can have an HTTPS / whatever your domain is .duckdns, and that's all free and easy to set up. So if you don't have your VPN working, then that is a way to get external access to stuff. So any questions before we get into the demo? Watching the YouTube chat. All right, well, feel free to ask questions anytime. So I'm just going to go over I'm just going to basically take the Raspberry Pi, this big one, because wireless is kind of annoying for demos, and we're going to set it up headlessly and then install Pi-hole and PiVPN onto it, because they're super straightforward. So you just pop micro SD card in your adapter. If you're on Linux, this is basically for Linux. It'll be a little bit different on Windows. You'll have to use Disk Imager, but it's a similar process. All right, so now we have projects, documents. So I have the Raspbian image file downloaded. You can get this from the Raspberry Pi website. Just Google Raspbian. This is the light version. Because we're setting this up headlessly, we never intend to use the desktop. Then this will run a lot better, especially on these Raspberry Pi Zeros. So we have the image. We're going to use DD. DD is a powerful tool if you don't know what you're doing. Be careful. Basically, we're saying DD input file, Raspbian output file. It's going to be /dev/sdd, I believe. It's good to check this, because if you screw up SDD, if you screw up, you can accidentally wipe your drive. And then we're going to do block size. If you haven't used DD or not super familiar, if you try to image a full drive with the default settings, it's going to take forever. This block size, basically setting it to 4 megabytes. You don't have to worry too much about it, but basically just do that if you're imaging something, because otherwise you'll be there all day. And then a little extra thing you can do is status equals progress. This will give you a progress bar. But in this case, it's pretty straightforward, pretty fast. This is all USB 3. So that's about it. We have imaged the SD card with Raspbian, but we're not going to be able to access this because SSH is disabled by default. So what we're going to do is go to media, to the boot partition of the drive. I just realized this is very small for you guys. Hold on. We're going to go to the boot partition of the drive, and we're just going to add a file called SSH. It's just a blank file. Just a blank file called SSH, no extension, nothing in it. And be careful if you're on Windows. Make sure you don't accidentally make it a text file or something. And what'll happen is when the Raspberry Pi first boots up, it'll delete this file, and if it deletes the file, you know it worked. And it's enabled SSH. So now we're done with that. We can just eject it. Oh yeah, I have it opened here. We're just gonna send it unplugged, no ejection. Now I pop it in your Raspberry Pi. I'm gonna have to plug this. I'll be right back. Alright, so we'll let that boot up, but if you're doing this with something that doesn't have a Ethernet connection, like the Raspberry Pi Zero Ws, you can do it with Wi-Fi. There are, be careful too, if you pick up one of these, the Pi Zero exists, and it doesn't have, without the W, it doesn't have Wi-Fi and doesn't have Bluetooth. You're going to need an adapter or something like this, an RS-232 cable, in order to set those up, or just plug in a monitor and stuff. But it's not much more for the W, and you should probably get it because Bluetooth and Wi-Fi are cool. But if you needed Wi-Fi, what you can do is, I think where this is, I didn't push D earlier. Yeah, so you can use, it'll be a file called wpa_supplicant.conf. This is like the template. So you just put your SSID in here and your password. And you just copy this file over to that boot partition, same place as the that blank SSH file we made. So it should be booted up by now. By default, if you have your host names working with your router and stuff, this is kind of the moment of truth. You can SSH pi at Ubuntu. It used to be pi at Raspberry. The newer versions of Raspbian changed that for whatever reason. And fingers crossed this will work. Getting a yes or a no. Okay, guess that's not working. In this case, you would go into your router. I'm pretty sure I know what this is going to be. And find the IP address of whatever it is. I may have to do that because demos inevitably don't work the first time. Okay. Yeah. Alright, well, I'm going to find the IP address real quick. That's the correct IP, it just hasn't booted yet. Yeah, let's try this again. Alright, well that's unfortunate. Luckily, here's one I prepared earlier because this always, or demos never work the first time. This one's fun because it is a Pi0W. Using this for another project, so I'm gonna have to fix it later. But let me just power it up real quick. And we'll install the stuff on there instead. Knowing my luck, it'll be working by the time we're done booting this one. The Pi0Ws do take a while to boot, like, I don't know, a minute, maybe more. I've never kept track, but give them a second. So it should be booted by now. And SSH into it, yes. Add the fingerprint. And we're in. Normally it would ask for the password. The password by default is raspberry. But in this case I have SSH RSA keys set up, so I don't need to type the password in. But you can, as soon as you log in with the default password, you do sudo raspberry config, and then you can get into this nice sort of graphical menu. I think this is called Incursus. This is the library that this menu uses. You'll see it all over the place with Linux tools. The first thing you can do, change the user password, and then update. And this will just do an apt update, apt upgrade -y basically. Check if there's any question. That ran away. What are you using the IP address for? God, it's me. So the IP address is basically the way that the network identifies your computers. So you'll have each internet connection will have an external IP address, and that's the same for everything on the network. Basically, that goes to your router, and then you'll have all the stuff on the network will have an internal IP address, and those are usually, I mean, most of the time they start with 192.168.1. something or .2. something. There's a whole lot more that goes into it, but basically it's just telling the computer which other computer you're trying to talk to. If you guys are interested, we can do a good network talk, which goes over different kinds of IP addresses, subnets, network levels. I've been thinking about doing that, so if that's something you guys are interested in, please let us know. But yeah, now we're done with this. We can go over some of the other stuff. So boot options, you can, this is the light version, so it doesn't have a desktop, but you can enable or disable the desktop here. So if you have if you do set up the Raspberry Pi with a desktop, you can always disable it later and get that performance back. Wait for network at boot, splash screen, these are kind of more advanced options. Network options, if you set it up with over LAN, or you set it up with a mouse and keyboard and monitor and stuff, you can use this to set the wireless settings. Some other stuff, overclock, whatever. Cool stuff is interfacing options. Like I said, it has the ability to do camera stuff built in. SSH we already enabled. VNC is like a remote desktop. We don't really need that. SPI is a serial interface, so is I2C. These are really common for like sensors and cool stuff like that. Sensors like motor controllers. If you're making some kind of robotics or IoT project, you might end up using these for some more advanced stuff. Serial, this is an RS-232 connection, so that's actually the same thing that this is. Basically, normally if you want to use RS-232 to some other embedded device, you have to plug one of these into your computer. Raspberry Pi has that built in, so you can just SSH into it and use that as your RS-232 adapter. Also has one wire. If you guess that this uses one wire, then you're wrong. It uses two wires. But that's nice for like if you just have a power and ground, you can get data over. It's really slow, but let's say you have something like you have it completely potted in like waterproof, and you just have two connections poking out, like this speaker, for example. There's just two connections that it uses to charge, and it's waterproof. That could be programmed with one wire, although I know that one's not, but could be. And then again, that remote GPIO I mentioned earlier is here. So that's that. We'll go ahead and set up Pi-hole and PiVPN. They're basically the same process. You just curl HTTPS, this website basically, and pipe that to bash. So what that does is it just goes to this website, it grabs this whole thing, and it just runs the script in bash. That's generally not secure, like not considered secure, but we're lazy, so if you really want, you can do what I just did and go and see what's on that website and read through this, or even you can use wget from the command line and copy it over to your own machine and run it. But now we're installing Pi-hole. Out of curiosity, I kind of bet that the other one works now. Maybe not. No. Okay, well, I killed that. It probably just needs like rebooted or something dumb. This is all a pretty automated process. Installing Pi-hole and PiVPN. Have to wait longer because this is on a 0W, which is fast. Also going over Wi-Fi. And I'll post the link to the slides in Discord after this. I have a bunch of links to all kinds of tutorials and projects and stuff. God, I messed it up. That I used if you want to set up any of these projects. So right now it's asking us to set up a static IP address. I know that this router doesn't reassign IP addresses. If you are on like a more complicated network, you may have to do that from the router. It's asking use an interface. This is because I'm not using wired. We'll go with LAN. That's probably gonna bite me later, but so this is asking about DNS providers. Basically, this is the normal DNS server that it's gonna go to if it's not an ad. It's gonna fetch the DNS records from this. Google's pretty good, but if you are against that, then yeah. These are the lists that it uses to block. So these are just lists that people update of like what websites serve ads. That's fine to just leave both of these on. IPv4 and IPv6, if you know what that is, then mess with that. Otherwise, ignore it. So yeah, here's our IP address. Fine. CX address. Yes, I'd like to install the admin portal. I'll show you that in a second. I like to log everything. And that's cool because once you have your router set up to point at the Pi-hole, you can actually see kind of an analysis of what all your web traffic is doing. Also, this is one of the kind of permanent installations you can run just fine on Raspberry Pi 0W. Like, it doesn't need a lot of processing power. Obviously, it would be faster if you have a lot of users on your network, or if you're just logging everything. It's usually better to have a Pi 3 or Pi 4. But the main thing is that wired connection. So if you just plug in a little USB Ethernet adapter, you can use a Pi 0W for this just fine. Except it takes forever to install. Still refused to. Doesn't work. I'm gonna check in a second. That should be. Alright, well, while that's going on, we can check out kind of what it looks like. I have a screenshot of the admin panel here. So you can see like your DNS traffic over time. Not it. So you can see your DNS queries over time. You can see where they get forwarded to. In this case, we just set it with Google, so they'll probably all get forwarded to Google. And you can blacklist and whitelist things. So if there's a site you want to block, you can do it through this. There's also like a few different kind of plugins available if you're interested in that. But in short, that's basically what that's like, and we're impatient, so we're just going to move on to the next thing. Okay, I just Control-Z'd that. That's a forceful kill. That probably broke stuff, but we'll have to find out later. That's the other thing. Similar install process. Curl pipe to bash. Again, if you want to wget this URL. I have other stuff on this, so if you want to wget this URL, you can download this, and then now you can check it and read through exactly what this will do. Then you can see the bash script with all the syntax highlighting. But again, we're lazy. We don't care that much about security. We're just a security club. So go ahead and pipe that to bash. Or you could even just run that script, but so that way you can very much ensure that it hasn't changed since you downloaded it and read through it. And so PyVPN is basically a little setup tool specifically for Raspberry Pis for setting up OpenVPN or WireGuard. The main differences between OpenVPN and WireGuard is OpenVPN's been around forever. It has more configuration options and stuff. But WireGuard is actually built specifically for Linux. It kind of integrates a lot more tightly with Linux. And because of that, it tends to run a lot better. It also has a few advantages security-wise, but OpenVPN is pretty secure anyways. One thing to note about WireGuard is unlike OpenVPN, it stores the IP addresses of clients on the server. So if you're trying to be completely anonymous and use, like, let's say you're purchasing a VPN for some privacy reasons, then WireGuard isn't going to be as secure. There's ways that people have tried to circumvent that, but just at its core, it's not really the same. Failed to install IP table. Okay, naturally this would break on both of them, but it'd give you similar incursus menu, just like the Raspberry config, and that'll walk you through, and you can read through. But for the PyVPN, it's basically just hit enter through it all and you'll be fine. And then you have to set up in your router, you have to forward a specific port so that you can access the VPN externally. And then the nice part about PyVPN is if you're doing this for yourself and you don't care much about configuration, to get like a certificate, it's just PyVPN space, and then you put in one of the there's a few different commands, but it's all super straightforward, and regardless of whether you're using WireGuard or OpenVPN, they're pretty much the same commands to do stuff like get certificates and add clients or whatever. So that's what I have for today. If there's any questions, I'll go ahead and ask. I think I messed up the latency a little bit, so take me a second to see them. Go away. All right, there's no questions. I'll be in Discord if you guys have anything. But yeah, thanks for tuning in. And yeah, you can create your own VPN. Now, I mean, it's still going to be on your own network. So difference when you're like buying a VPN, you're going to another network with a bunch of people that are sharing the same VPN. They're sharing the same traffic through the same IP. If you create a VPN on your own network and you use it from within your own network, you're just kind of wasting your time. But let's say you're at a hotel or something and you don't really, and you want the security that comes with a VPN, then you can connect to your VPN and all your traffic will go through your home network, and it'll be encrypted while it's on the hotel's network. I'm glad I could help. There's a lot more in-depth stuff. I've worked with Raspberry Pis on various projects for hackathons to do all kinds of weird, crazy things. But yeah, these are just, if you have one laying around, easy stuff to do. So yeah, that said, thanks for tuning in, and I'll see y'all guys next week.